Good morning, and welcome to the Royal Swedish Academy of Sciences and this press conference with this year's Nobel Laureates. I'm Göran Hansson, I'm the Secretary General of the Academy, and it's my privilege to introduce the laureates. First, this year's Nobel Laureates in Physics, Professor Weiss, Barish, and Thorne. The Nobel Laureates in Chemistry, Professor Jacques Dubochet, Joachim and Richard Henderson. And last but not least, the Laureate in Economic Sciences, Professor Richard Thaler. And as you know, this week is the culmination of a work that's been going on in this building for several years, with nominations, evaluations, reports, discussions, intense discussions, and culminating first in the announcement of in the decision and the announcement that we made in this room a couple of months ago. And now we're extremely happy to have our Nobel laureates here to give their lectures tomorrow, and then the prize awards ceremony on December 10th, on Sunday. I won't say much more. It's your show, so feel free to ask questions to the laureates, and we'll do it very informally from there on, but raise your hands and then you'll get a microphone and you can pose the questions. Who'd like to start? Don't be shy. They are overwhelmed by the collected, assembled intellectual brilliance in this room. That's clear. We have, Maria Gunther.
My name is Maria Gunther from Swedish newspaper Dagens Nyheter. I have a question to all of you. I would like to know what you donated to the Nobel Museum and why.
What you donated to the Nobel Museum yesterday. Who would like to start? Barry.
I donated the 2 photodetectors that were the first detectors that have ever detected gravitational waves, which we pulled out of the apparatus.
To add to that, I didn't know that Barry was going to do that, but I brought an old photodetector that I had built myself from 1972. It's a piece of junk. It's not here yet, but there's a picture of it, and it was sort of the first of those detectors, water-cooled, to be able to use in a big interferometer like that.
So I'm a theorist associated with the same project, but I did design one piece of experimental apparatus, baffles to control scattered light, and so I donated a piece of a baffle. I'm so proud that as a theorist I could design something that actually appeared in the instrument.
Great.
I donated the plunger we used where we obtained the first visible and in the electron microscope droplet of vitreous water.
I donated a box around 11 pounds, a very big box, and it contains mounted slides. Each contains a contour. So mounting it at a correct distance produces a three-dimensional view of the molecule. At the time in 1987, that was the only way of visualizing a three-dimensional structure. And this was the structure shown is the first one that was done with a single particle reconstruction method.
And I donated 2 things. One was another contour map of the membrane protein bacteria rhodopsin, which was printed out in October 1974 from work that Nigel Unwin and I had done on unstained biological structures. Prior to that, most of the structures that had been done used heavy metals to be visualizing the structure. And then the second item was a 3-dimensional model of the same protein that was made from a map that was calculated in 1990. The model was made in 1993 by a little company at Edinburgh University, where I was an undergraduate, called Beaver's Miniature Models, which is a company that makes molecular models with people who are deaf. So it's a handicapped organization, and any of you can buy hundreds of different models of different compounds, including bacteriodopsin, if you'd like.
Dr. Thaler.
So I donated something that will seem quite odd, which is a coffee mug. Cheap. But it's a mug that has some historical significance. An experiment that I ran with my friend Danny Kahneman, who was a Nobel Laureate 15 years ago. We were trying to demonstrate something that I have called the endowment effect, which is once you have something, you don't want to give it up, though before you had it, you wouldn't have been much interested in having one. And so we ran an experiment in which we gave half the people in a classroom one of these Cornell mugs. I was teaching at Cornell at the time. So Cornell insignia mug, and the other half didn't get a mug. And then we conducted markets in the mugs, and most of the people who got a mug kept them, and most of the people who didn't have a mug didn't buy one. And so this is the last mug that I have from that experiment, and it's now well preserved here in Stockholm.
We'll make sure you get a coffee mug from the Academy of Sciences to bring back to Chicago.
I'll be back to my equal. Actually, it's become, the curious thing is there have been hundreds of experiments replicating this finding, and I'd say they all use coffee mugs. And I should have gotten a bonus from whoever makes ceramic coffee mugs, because I've sold thousands of them. But so I have lots of mugs, but not that one. That's the last one of those I have.
Great. Please, the lady over there.
Hello, my name is Tira Tronstad. I come from Obosbladet, Norway. I have a question for Richard Thaler. My question is, a lot of your research has started with rather small observations from everyday life. And I'm wondering, have you seen anything interesting recently that you'd like to investigate further that you can share with us?
Well, I've actually, since last summer, have been doing a bunch of research on the Swedish pension system. And I won't say much about the findings because we'll talk about it a bit in my lecture and then later next week in Parliament. But what I will say is I have one slide that has the title, "We cannot reject the hypothesis that 3 million Swedes are asleep."
Wow.
One of them being Per Stromberg, who's the chairman of the Economics Prize Committee. We have data on everyone, so I know exactly what Per's been doing.
I'm sure that's a message that's well received in Norway in particular. The Swedish population is asleep. More questions? Gentleman over there.
This is to the physics prize winners. What do you foresee will be the ultimate or the penultimate impact of your discovery relating to detection of gravity waves? Small question.
So the laws of physics tell us there are only two types of waves that can travel across the universe, bringing us information of what's on the other side: electromagnetic waves and gravitational waves. Galileo opened modern electromagnetic astronomy when he pointed a small optical telescope at Jupiter, discovered the 4 moons of Jupiter. What the LIGO team of 1,000 people, for whom we are basically icons, has done is the analogous thing to what Galileo did 400 years ago. We pointed, well, they built gravitational wave detectors and saw gravitational waves from colliding black holes very far away. When you look at what's happened with electromagnetic astronomy in the last 400 years, the changes in our understanding of the universe due to observations with light, with X-rays, with radio waves, infrared radiation, gamma rays, ultraviolet radiation, all different forms of electromagnetic waves. The universe we see is radically different than Galileo's universe. And can you imagine what our descendants will say 400 years from now is the universe that they have learned about through gravitational waves, through these waves that penetrate far more powerfully than electromagnetic waves, these waves that are capable of observing the birth of the universe. What radical changes will there be in our understanding of the universe in the next 400 years? I can't say, but our descendants will know.
Thank you. Who's next? The lady over here.
Thank you. Hello, I'm from the Spanish news agency EFE. I just want to know, I think we live in an age where science seems to be under attack, or even worse, it seems to be just an opinion. So I would like to know, what do you think about this situation, if you agree with this reading I'm doing, and what could be the consequences?
So, science under attack. Fine. Anyone who'd like to take a shot at that one? Under attack by, from what? Could you maybe?
Yes, sorry. I think nowadays it seems that science is just an opinion, not something real, something that everybody can trust. So I want to know if you agree with this, with that, and what could be the consequences.
How can science compete with alternative facts and prejudice? Who would like to comment on that? Dr. Dubochet.
Science and opinion. Science is knowledge. Knowledge is what makes what we are. We are sitting, you are sitting in front of your computer, and billions of people are sitting a long part, or not billions, are sitting in front of the computer a big part of the day. When we observed for the first time our vitreous water, this was the year, no, it was it was about the time when I got my first personal computer. In 35 years, our life has changed because scientific discovery has changed it. It was not pseudo facts. It makes that life is different. My father's grandfather was living in scarcity. We are now living in excess. Our world is changing. These are not just invented facts. These are facts, and our atmosphere is getting crazy. These are also facts. These are science, and we better listen to that. Thank you.
Thank you. Dr. Henderson?
Yes, so I thought I might mention a story from the first director of the lab where I am now in Cambridge, MRC Molecular Biology. Max Perutz was that director. At one point, we opened a new lecture theatre and asked would he mind if we named it after him. And he said, yes, provided his motto could be put on the lecture theatre. And we asked him what it was, and his motto was, in science, truth always wins. And his argument was that in other areas, perhaps economics or politics, there are always more than one side to each argument, two sides, and particularly in the media, they like it if there's an argument, even if one side is complete nonsense. But Perutz's idea was that in science there is evidence, and in the end, after a lot of argument, there is only one truth, and nature always tells you what's right, and that was the idea. So I'm relatively confident about the future of science.
Let me just add
Please.
one thought provoked by that, which is I think we can distinguish in science between facts and interpretations. One of my friends and colleagues won this prize 4 years ago, Eugene Fama, and we have quite different views about how financial markets work. But the way Gene always puts it is, we agree about all the facts, we disagree about the interpretations. And I think that's where we have to be, is at least agreeing on the facts. And then we can have our fights about which one of our theories those facts support.
Dr. Frank.
I think I also have an optimistic view on this matter. Through demagoguery, we now have a situation where a certain section of the populace believes that science is just a matter of opinion. And I think it's our responsibility as scientists to take an active role, especially in education, in science education. And I think that has to start very early in school. We no longer, in this era of internet buzz, we can no longer sit back and trust other people to spread the message. I think we need to have a more active part in this.
Thank you. Who is next? We have a question over there, I believe, although I cannot see who is waving. Yeah, there, the gentleman standing there with the camera.
Thank you very much. David Keaton from the Associated Press. I think for lots of people outside of the world of science, there was two questions that are very interesting. The one that the lady over there asked about the impact of Science Day in the political world. The other one is obviously about gender representation in the world of sciences. We look here, 7 gentlemen representing the finest of scientific discovery here, but you are all men. To what extent is this a limitation to sciences, and to what extent must this change, or can this change, and what are the limitations to this change actually happening and occurring in your respective fields, please?
Gender and science. Dr. Barish?
Yeah, I think we all agree that the change has to happen and is happening, both, but it's slower than we'd like. And so it takes a proactive approach back to youth to convince both genders to be in science, minorities to be in science. And it's, of course, we're not as well off as we could be in doing science if we're limited to just white males. We all know that. And there is change. We can register the change even in physics, which is a hard one, but it's slow, and we have to be very proactive to try to make the changes.
I think just one simple statistic. Barry and I are at Caltech. It's a technological institution. It's essentially all science and engineering and mathematics and economics. When I was a freshman, and we are all representative of that generation, when I was a freshman, there were 0 women in my entering undergraduate class. Today, the entering undergraduate class is roughly 45% women. Change is coming, but there's a long delay between an entering freshman and the Nobel Prize.
Dr. Dubochet?
Female are none on this row. But wait, it will change. Science has been made by male, for male. It's changing, and it takes time, but you will see. They are coming. Yes.
Dr. Thaler.
I would just add that in economics we would call this a lagging indicator. You notice it's right that we are all white men. We're also all old white men, and all of these projects have been going on for 30 years or longer. Certainly in economics, there's a very strong wave of younger women that are, many of them, the leading lights of the profession. But the vanguard of that group are in their early 50s, and there are many more in their 30s and 40s, and they'll be up here, but it will take a while. If you want more leading indicators, I think in economics we give a prize to the best economist under 40, and I think 3 of the recent winners were women. The last 2 editors of the American Economic Review are women, and so it's happening, but don't expect to see the first signs of it here. It's happening in other places, and it'll get here.
Okay. Thank you. More questions? Over there. Yes, please.
I'm Corina Negra from Radio Romania Science Department. I have 2 questions, if it's possible. The first one is for the physics laureates. So, and maybe the chemistry, but mainly for physics. What do you think will be the next theory that will be experimentally demonstrated by the technology, by the technological advance? Because Virgo, LIGO, Higgs a few years ago was possible because of the technological advance. So is there any theory you expect to be demonstrated, experimentally speaking? And the second one is a general one about the people not trusting so much science. To what extent do you think it's the scientists' fault being sometimes under pressure to provide results, to run for funding, and to provide, I don't know, wrong results? Thank you.
2 hard questions. Who'd like to start with the next discovery in physics?
Well, I wouldn't tie it necessarily to theory. We don't, at least in physics, we don't always have the kind of plan we had for gravitational waves, where we were trying to follow up a theory that was 100 years old. Often it doesn't come that way, but the advances in technology are giving phenomenal potential in science. I think the one that's coming on the soonest that's different is the large surveys in astronomy. So the large survey, the biggest project is called LSST, the Large Synoptic Survey, and which will take a detailed picture of the sky 2 or 3 times a day and watch for changes. And I think that inevitably has to be a much more systematic way of doing astronomy. It's all experimental. It's not being forced by theory, but I expect, and that'll be operational within the next 3 or 4 years. And I expect that we'll see very big results from that survey. So if I had to pick where it's going to come next, I would say that the large surveys in astronomy.
Let me try and answer a different kind, which Barry would have given also. Sorry. That is that, what are the things that we worry about the most right now? In terms of I don't want to call it theory. I'll call it phenomenology and natural philosophy. And that is, we have a wonderful theory of space and time, and this gravitational wave thing is part of that. But we have a very active theory that is very done every day, which is the quantum theory of matter, the quantum theory of of light, the quantum theory of almost all other fields. And I mean, many people have said this, but you ought to know that it's not just them. All of us feel this way, that there's got to be a synthesis done between the large-scale theories, which deal with space and time, which is like general relativity, and the day-to-day theories that have to do with the things on the small scale, which is the quantum theory. And that's still a huge puzzle, I think. Kip ought to say better than I, but to me, that's the place, that's a frontier in physics. And I'm not a theorist, I'm an experimenter.
Dr. Thorne, do you agree?
Yeah, certainly I agree that the golden ring, the big prize among us physicists is going to be for really understanding the synthesis of quantum theory with general relativity, the so-called laws of quantum gravity. There has been great progress made toward that in the last few decades, but there's still a long way to go. But we know that it's those laws of quantum gravity that control the birth of the universe. How was the universe born? We will understand it much better when we have the laws of quantum gravity. They control what happens inside a black hole. The so-called singularities inside a black hole are controlled by those laws. And at least Stephen Hawking and I believe that those are also the laws that control whether or not you can go backward in time. And so these big, fascinating questions all depend on unknown physical laws. And as the theorists push forward toward understanding those laws, there will be experimental data, I am sure, that will give us insight into whether or not they're on the right track in due course. And it will be an interplay between theory and experiment that is going to be, I think, one of the most exciting things that goes on over the next several decades in physics.
If I may extend that to chemistry, what do you think are the main unresolved problems in biochemistry, structural biology? Are you able to solve all the structures you need now, or are there more challenges that will require new technical development? How do you see it? Dr. Frank?
Well, I think solving structures is not enough. We need to know how these structures interact with one another. And so what needs to be explored is really the dynamics of these molecules. And the wonderful thing about the cryo-electron microscopy is that it gives us many hints because of the very large data collections that we make and to the millions of molecular images, we actually are able to capture molecules in many intermediate states. And so we have essentially sort of tracks of conformational changes between the different states. And this is an area that, in my opinion, is entirely unexplored. So we, in terms of what cryo-electron microscopy has achieved, we now sort of are on par with X-ray crystallography, but we can go far beyond because we are able to look at multiple states that the molecule can attain. In fact, we can now look at an entire continuum of conformational changes. So we can map the workings of molecular machines by this technique. And so we have a very far way to go to explore this all.
Thank you. Seems you all agree. What's the next frontier in economics?
Well, I'll say two things. I mean, I think the place where the equivalent of technology for economics is big data. And many of the most exciting findings now are coming from the fact that we just have massive amounts of data, and we know where everybody is all the time, and what they're buying, and what they're reading, and that will provide the equivalent of a powerful microscope. And we're learning all kinds of things about inequality, for example, and how it happens. And so that's the future. I would say that the last 20 years or so has been, or at least should have been, a humbling experience for the economics profession. We've seen a series of events that many economists would have said could never happen, starting with a crash in October 1987 when the stock market all around the world fell 25% on a day with no news. This should happen every billion years or so, according to the theory. And things like that have been happening once a decade or so. So that seems too often. The financial crisis shouldn't have happened. We still don't know why it happened. And I think in the best sort of science, I think we're learning more about what we don't know.
And isn't that a great... Oh, we're running out of time, I'm afraid. But I know that you have requested individual interviews, and that will commence right away. But I think that was a great note to end on, and we know that there is fantastic discoveries made, still a lot to do. Science is progressing, as is hopefully mankind. Thank you very much.